Okay, this is our third lecture, and in the previous lecture we have discussed about Cartesian coordinate system, right? So in the Cartesian coordinate system, what were the main formulae you need to remember? It's just quick recap about formulae. So in Cartesian coordinate system, you have studied how to write the position vector, right? For any point, for any given point in a coordinate system, how to write a position vector for this. So you can write P x ax plus y ay plus z az. It is the position vector P, and ax, ay, az are the base vectors to indicate the three components of the position, the three components of the point P, or the position vector P, which is along x and y, x, y, z axis. So then you have written the distance vector. So when 2 points are given, P of x comma y comma z and Q of P comma Q comma R, when two vectors are given, or it's better to write x1 y1 z1 rather than PQR. Take it as x2. It's not wrong, but to make it simple. So how to write the distance vector PQ? That is nothing but vector Q minus vector P. So how you can write? Directly you can write x2 minus x1 into ax plus y2 minus y1 y2 minus y1 into ay z2 minus z1 into az. Okay, this is the distance vector. And how you can obtain magnitude of any vector? That is under square root of. In case of position vector, it is directly x square plus y square plus z square. In case of distance vector, it is under square root of x2 minus x1 whole square plus y2 minus y1 whole square plus, just a minute, let me check the sounds. Okay, so then, so it is y2 minus y1 and z2 minus z1 whole square, which is under root, right? So this much you have studied in the previous session. Similarly, in all the same cases, and one more, a small bit of Cartesian coordinate system is left, that is differential elements in coordinate systems. So what exactly the differential elements? First try to understand what is the meaning of differential elements. In simple words, in layman words, you can understand differential elements in Cartesian coordinate system. Okay, so say for example, when P is given, it is x, y, z. If this P is slightly moved to the other position in the same coordinate system, then P dash is formed. That P dash is nothing but x plus dx, because differentially the x coordinate or the x point is slightly shifted to the other position, and that slight shift is that distance is dx. So when the original point x is added with the differential point dx, then you will be getting the new point, and that is x plus dx. Similarly, y plus dy, z plus dz. So these dx, dy, dz are differential elements. These are nothing but the differential elements. Okay, so dx is the differential length of a new vector or differential vector in x direction. Dy is a differential length in y direction. Dz is differential length in z direction. Quickly, I'll try to represent it in a coordinate system. Hope it is more clear to understand. If not, it's okay. So say this is point P. Okay, this is point P dash. This is given already, x plus x comma y comma z. And if you shift this point, you are not taking the other point over here, you are just trying to shift this point. You have shifted to this point to P dash. P dash, where x is shifted with a dx element, y is shifted with dy element, z is dz element. So the new coordinates will be x plus dx plus y plus dy. Try to visualize z plus dz. So, and the vector joining the previous point and the differential vector, that is differential vector, and the length of such differential vector is represented as dl. The differential length can be given as dx square plus dy square plus dz square. When this shifted or displaced point is formed, if you draw the it creates some parallel. So what happens, and there forms the volume, that is a differential volume, which is dx, dy, dz. And differential surface is also formed. Differential surface is ds an. So differential surface is vector quantity and differential volume is scalar quantity. Length is vector quantity. Okay. So again, what is an here? The new term an, right? That is unit vector normal to the surface. That is again unit vector which is normal to the surface ds. Okay. So how you can write, if you want the differential vector surface area or the differential surface area in normal to x direction, so you can write it as ds ax. What is this? Differential surface area normal to x direction. Similarly, you can write dsy, differential surface area in y direction, dsz, differential surface area in z direction. Try to remember these. So whenever you define a point in any coordinate system, the differential moments or the displacement will be considered, or the displacement of that particular point will form a other coordinates, and the distance between the new point and the previous point or the initial point, that gives some length. That length is nothing but the differential length that can be calculated as the differential elements. Those elements are nothing but dx dy dz in Cartesian coordinate system. This is purely regarding Cartesian coordinate system. This is a small bit which I haven't touched in my previous class. So let's wind up the Cartesian coordinate system. Okay. Feel free to ask any questions. It might be silly or it might be the application level. Whatever it is, feel free to ask questions in comment box, so that it's more helpful for me to clarify or to understand the level of the students, how much they are receiving, how much you are expecting from us. Okay. The next important coordinate system is cylindrical coordinate system. See, how I have taken for Cartesian coordinate system, I'll not take that detail for cylindrical coordinate system. I'll directly define the coordinate points, that is r, phi, z. R, phi, z are the r, phi, z are the three variables here, as x, y, z were the coordinate points in Cartesian system. Here you are having r, phi, z. Okay. Only thing you have to understand what exactly the r here and phi and then z. So for that I'll be drawing here x, y, z. So the surfaces used to define the cylindrical coordinate system are plane of constant z. So constant z means it is parallel to xy plane, right? It is having the arc length, the radius and the axis. So how exactly you can define here is, let me take a point P in this cylindrical coordinate system, and I'm drawing the cylinder at particular point P. At particular point P, okay. Here the distance from x axis to the point P is r. R is nothing but radius of the cylinder. R is nothing but the radius of the cylinder. Okay. Next, the term is the half plane perpendicular to xy plane at an angle of phi with respect to z. So phi, you have to define phi here, phi. So I'll be drawing the dotted line to this point, to this point, and the angle between this point is phi. Okay, this is phi, and the distance, this is r and it is z. R, phi, z. Don't worry about the diagram. You just have to understand R, 5, Z are the 3 points in the cylindrical coordinate system. Now, the next question is how to write the vector. When the vector or when the points are given, if the points are given, then how to write the vector, that is P r A r plus P phi A phi plus P z A z. Okay. P r is nothing but r, P r is nothing but r, P phi is nothing but phi, P z is nothing but z. Okay. So by this what you can understand? You can understand AR, A phi, AZ are 3 base vectors in cylindrical coordinate system. As I defined differential elements for Cartesian coordinate system, here for cylindrical coordinate system also there are differential elements. dr that is the differential length in r direction, d5 is an angle. So how to find out the arc angle? That is nothing but r d5. See, by diagram you can understand, it's a basic mathematics. R d5 is a differential length in a phi direction and dz is differential length in z direction. So can anyone tell me the magnitude or the differential length vector? So first one is dr square, next is r d phi square, then the dz square, right? This is differential length. And differential volume, multiplication of 3 coordinates, that is dr is first, then r d5, then dz. So what is the final equation? R dr d5 dz, r d5 dz. This is the volume. Then comes the differential surface area. Differential surface area. So ds r, which is the differential vector surface normal to r direction, that is nothing but excluding dr r d5 dz in ar direction. Similarly for ds5, excluding r d5, you have to write dr dz a5. So for ds z, excluding dz, you should write the other terms, that is dr r d5 in az direction. So summarize the formula. So what and all we have written. If you can't understand the logic, try to understand how to write, like which one to exclude. See, when R is mentioned here, that means it is in AR direction. So what you have to do, you should exclude R component here. That is a logic. Just make one logic and try to remember the formula. This is about the cylindrical coordinate system.